We were thinking about problems when a firm is having difficulties in the short run. We're talking about situations with short run equilibrium in a situation like this. This short run equilibrium would have price and at P0 would have marginal revenue equals marginal cost right at this point, and we call that Q star. And we understood that at that point, this gap, we'll do it in red, this gap would be equal to price minus average total cost. And if we were to multiply that times output, we know that the definition of profit is just basically output times price minus average total cost, which unfortunately for this firm, price minus average total cost is in fact a negative number. Not a good deal. And so the firm is losing money. And so the firm has to make a decision. Should I continue to go ahead and lose money and wait for take the long run to come and I can get out from underneath the brick and mortar? Or should I just lock my gates and wait for the long run to come? Either way, I want to get out of this industry. But in the meantime, should I keep producing or not? And we derive something called the shutdown condition. All right. And so the shutdown condition that we discovered was that your firm will shut down if total revenue is less than variable cost. Well, we want to make this a little bit easier. So what we're going to do is we're going to rewrite it. Okay. So we're going to rewrite total revenue less than variable cost. Well, I know total revenue is just price times quantity, right? That's total revenue, P0 times Q star. And this term, variable cost, well, I got to put a little blurb here. Recall that the definition of average variable cost was equal to variable cost divided by output. So if I were to multiply both sides by Q, multiply both sides by Q, I would get Q times average variable cost equals variable cost. And so I can substitute over here and say I want to pick average variable cost and multiply it times Q star. So my shutdown condition is when this term, which is total revenue, is less than this term, which is variable cost. But since they both got Q stars on both sides, I can divide through by Q star. And as long as Q star is non-negative, it doesn't change the direction of the inequality. So let's just knock out this, and that means that I can rewrite this as price. Oops, I don't want to use that red. I can rewrite this as price less than average variable cost. Price less than average variable cost would indicate that you should shut down if price is less than average variable cost. Okay, so let's see if we can graph that. I'm going to put a picture up here and redraw these graphs. And I've got a marginal revenue curve. And that marginal revenue curve is horizontal at price, B0. And I'll put marginal revenue, the axis system, Q on the horizontal, and dollars and cents on the vertical. And I've got some marginal cost curve. And I have an average cost curve. And the firm in this situation would know that marginal revenue equals marginal cost, where at the output we'll call Q star and that firm is losing money because price is less than average cost. So this would be the area of losses, negative profits. Now the question is, what about shutdown? Well, in order to know something about shutdown, we know the shutdown condition was price less than average variable cost. So I have to put average variable cost back on this picture. Where is it? Well, I know average variable cost is also U-shaped, and I know it has its minimum along the marginal cost curve. So I can draw it because I've got the pen. I'm just going to draw it right here. Remember that the average variable cost and the average total cost asymptotically converge to each other because at very high outputs, average fixed cost is getting really, really small. But that's not important right now. What's important is that you can see that at this output point, okay, at Q star, price is greater than average variable cost. Price is greater than average variable cost, so we're not going to shut down. We're going to keep producing. Now, that's because I arbitrarily drew that average variable cost curve right there. You can imagine instead, I've got the pen. I'm going to draw the average variable cost legitimately. I can do this as being something like this. It's U-shaped. Has its minimum along the marginal cost curve, and it looks something like that. So if I had drawn it there, what would the solution to the problem be? Well, the firm would maximize profits by producing where Q star, where marginal revenue equals marginal cost. But in this particular situation, the price is less than average variable cost. If price is less than average variable cost, shut down. So in this situation, how much would the firm produce? 0. The firm can't get out from its fixed costs. Those fixed costs are sitting in the corner of the room like a 900-pound gorilla. It's a $1 million fixed cost. And on the previous picture, the firm did not shut down because price and therefore total revenue was in excess of variable cost. So by having the doors open, the firm made enough money off the workers who came to work that day to pay those workers their wages and still has some change to put towards the fixed cost. In this situation, the workers who come in, you're paying them $40,000 and the value of the product they're producing is only $30,000. So you're losing money on your workers coming to work as well as that pile of fixed cost in the corner of the room. So you're just going to shut down and wait for that phone to ring.